systems. This is the method of body generation energy which is demanded by the intensity and duration of exercise. Activities like jumping or sprinting will require short bursts and require the body to produce large amounts of energy over a short period of time. Whether a marathon runner or a cyclist requires the body to provide continuous energy, producing over a long duration of time and at a slower rate. Adrenaline triphosphate is a molecule that stores all and releases chemical energy for use in the body cells. ATP consists of a base, adrenaline, and 3 phosphate groups. It is formed by a reaction between ADP molecules and phosphate. ATP is a versatile molecule that can be used for many things. Energy is stored in the chemical bonds, and when they are broken, energy is released. When a bond is made, energy is stored. Energy systems of the body can function with or without oxygen. Any movement that requires sudden bursts are powered by energy systems that do not require oxygen. Anaerobic systems where physiological activity are required. Aerobic require systems that require oxygen.
Energy is required in order to make muscle fibers contract. This is obtained from the oxidation of food within the diet, and particularly carbohydrates and fats. Carbohydrates are broken down into a simple sugar called glucose. If it isn't required immediately to your body, it is converted to glycogen and is stored in the liver and muscles. Fat is broken down to form free-form fatty acids as well. When these substances are burned in the muscle cell, ATP is formed. When ATP is broken down, it gives you energy for muscle contraction. This is the only molecule that can supply energy used in contraction of muscle fibers, and it can be made in 3 ways: creatine phosphate energy system, the lactic acid system, and the aerobic energy system. These 3 systems we are now going to explain in further detail, starting with the creatine phosphate energy system.
The creatine phosphate system is the shortest of the 3 energy systems and makes up the ATP-PCR system. Creatine phosphate is a high energy compound. When you exercise at high intensity or the energy is needed instantly, PCR stored in the muscles is broken down to provide energy to make ATP. In this process, ATP is usually made without the presence of oxygen. Explosive work can be achieved, but only up to about 10 seconds at maximum intensity. The supply of PCR is limited. Lactic acid energy system is a short-term energy system. To meet the energy requirements of higher intensity over a period of time, such as during a 400-meter race. ATP can be made by the partial breakdown of glucose and glycogen. This whole part of the system is done without oxygen, so it means it's anaerobic. This system will last around 60 to 90 seconds at maximal performance. The lactic acid energy system will be used for sports like 400 meter sprints, as shown earlier, as well as football to an extent when playing or officiating. Aerobic glycolysis will only begin when the ATP PCR system has finished, so that will be after the 10 seconds that system lasts. This part of the system will then begin by breaking down the liver and muscles glycogen stores. Due to this system not using oxygen to aid energy production, this causes a byproduct to be produced called lactic acid, which limits the amount of energy produced. Lactic acid is a limiting factor of anaerobic system. It accumulates and diffuses into tissue fluid and blood. If this substance fails to be removed by the body and builds to impede muscle contraction and cause fatigue. This you may have felt before as an uncomfortable burning in your muscles during intensive exercise. The aerobic energy system is the last system in the line. This is the only energy system that uses oxygen, and because of this, the byproduct of lactic acid is not made, which means the body will be able to work for longer, for example, during team sports like basketball. Because oxygen is able to be used in the energy system, this will create a lot more ATP. This will happen after the ATP PCR has finished. This energy production occurs within the mitochondria of the cells. These are the power stations of the cells responsible for converting food into energy. The production of this system is slow to engage because it takes a few minutes for the heart to deliver oxygenated blood to the working muscles. With this system, long, continuous and moderate exercise produces energy within this system. During exercise, the body does not switch from one system to another. Energy at all times is derived from all three of the systems. The different sports that use the systems are shown in the following image. Any exercise will represent a stress on your body and will disturb its natural balance. Depending on the intensity and duration, this disturbance will vary. For a total recovery from exercise will depend on a number of factors, including the restoration of immediate energy system, the removal of lactic acid, and the respiration of muscle glycogen. The PCR system can be restored as quickly as the energy released from the system. This makes it possible to repeat short bursts of energy without becoming exhausted. However, once lactic acid is produced, it will take around 45 to 60 minutes for that to be removed from the system. The rate of muscle glycogen restoration depends on the choice, speed, and amount of carbohydrate consumption after exercise. In the next few images, you will see training methods and what energy systems they use.